Greetings, M squared here. Today we're going to talk about standard form of a quadratic function. I want you to notice that there's no parentheses. Standard form has an ax squared, a bx, and a c, so it's a quadratic trinomial. Now, the quadratic piece has to be there or it's not quadratic, right? This term, but the b sometimes isn't there, the bx, and the c sometimes isn't there, but this one will always be there. And it's not like vertex form. You can't just look at it and see the vertex, but you can, on this one, you can see the y-intercept. C is what we see, the only thing that we can really see when we look at it, that we would, a point that we would graph. So C is the y-intercept, and that's because the y-intercept, that line, the y-axis, is called x equals 0, and if x was 0, the only thing that would be left here is C, because these would zero out. A tells us the same thing as it did in vertex form. A tells us whether the parabola opens up or down, and it tells us whether it's vertically compressed or vertically stretched. But here's the different part. It's a little bit more tricky to find the axis of symmetry and the vertex. So we're going to start by finding the axis of symmetry, because the axis of symmetry, remember, is the x-coordinate of the vertex. So if we can find the axis of symmetry first, we can plug that number back into the equation and find f of that number, which helps us then find the y-coordinate of our vertex, and then we can graph like we normally do. So that's what we're going to do. We're going to use this formula. Now watch, the formula for axis of symmetry, remember it's still an equation. It's always written as an equation, and the only variable it has is x. So x equals negative b over 2a. This b and this a are the coefficients of the quadratic and linear terms. So you have to know what's in front of a and what's in front of b, what those numbers are, before you can find the axis of symmetry. And again, remember, you will always have an a. It will always be there. It might be 1, but it will always be there. Sometimes b is 0. When b doesn't show up, when it's just like 4a squared plus 3, no x involved, then you know that b is 0. And then we'll talk about more of this other stuff, but today we're going to focus on graphing. And to graph, we need the a value, which they'll give us, and we need the vertex. To use our pattern, our 1, 3, 5 pattern, we're going to need the vertex and the a value. So let's get started on figuring out what a, b, and c are. We're going to just refresh our little memories on how to do that. You can also look at your reference sheet. You know, we have the how to find the range and the domain, and we'll talk more about x-intercepts later. And again, I mentioned the c. This is important. F of 0 is how I get my y-intercept always, and the y-intercept is going to be our c. So first of all, let's just talk about an equation and what a, b, and c are. How do you find a, b, and c? If it's not in standard form, which they probably all will be, but if it's not, remember you have to look at in front of x squared to find a, and the number in front of x squared is 3, so a is 3. You have to look in front of x to find b, and don't forget the sign. That says minus 6, so we have to say that's negative 6, and then finally our c is 5. Remember, the only thing we can see from looking at standard form is the y-intercept, and it is c. So when I ask, what's the y-intercept? You'll say, oh, that's c, and in this case, it's 5. Does my parabola open up or down? Well, it's positive. A is positive, so it opens up. Next, I have to find my axis of symmetry. You're going to have to memorize that formula. The axis of symmetry is x equals negative b over 2a. So first I find b, and it's going to be negative, or the opposite of whatever b was. That's what negative b means, the opposite of b, over 2 times a. Well, 2 times a is 3, and a negative 6, those negatives will cancel, so I end up with 6 over 6. So my axis of symmetry is x equals 1, because 6 divided by 6 is 1. That gives me half of the vertex. But in order to find the rest of the vertex, I have to find f of 1. That means I have to find out what y is when x is 1. So I go up to the original problem, and I say 3x squared minus 6 times x plus 5. But instead of x, I put 1, because that's what I'm trying to do, finding y when x is 1. That's what this means, y when x is 1. F of 1 means what's y when x is 1. So 1 squared is 1, times 3 is 3, minus 6 times 1 plus 5. 3 minus 6 is negative 3, plus 5 is 2. Now I know my vertex. So if I wanted to, I could graph it, because I could graph my vertex and use my 1, 3, 5 pattern. But today we're not graphing, we're just investigating and trying to find A, B, C in the vertex and the axis of symmetry. That's all we're doing with today's. So remember that our domain and range, so if we look back on our little reference sheet, our domain for all of these are going to be all real numbers. It's always the case with parabolas that open up or down. So that's the easy part. All real numbers is going to always happen because the graph goes left forever and it goes right forever. And domain is all about the x values, which go left and right. Range is about the y values, and they go up and down, all real numbers. To find our range, it's always a y, and it's always this y coordinate. So it looks a little funny here. Remember our hk from last time, we just used k. Well, now this is our k. This is f of negative b over 2a. Remember, that's the axis of symmetry, and the f of that means what y is at that point. So if you remember, that's just k. Once you find your vertex, you can say, oh, that's just k. And so if the graph opens down, I shouldn't have said absolute value here. Absolute value can't be less than 0. Oh my, finding mistakes all over. That shouldn't be there. If a is less than 0, then you need a less than sign. And if a is greater than 0 or positive, you need a greater than or equal to sign. So since we open up, we know that it's going to go like this. We know that it's going to be start here, and then all the y's are going to go up after that. There aren't any y values below this parabola. So we say y is greater than or equal to, and then we use the y coordinate. So it's just 2. And then it says, is the vertex a maximum value or a minimum value? Well, right here, it's the lowest value, y value, of any point on the parabola, because they go up forever. So we're going to say that's a minimum. So when it opens up, it's a minimum. Let's try another one. Okay, first we're going to find our a. Remember, it's in front of the x squared, so that's negative 2. This is in front of x, and the signs are important, so I need to put those signs in. And now we want to know if it goes up or down. Well, since a is negative, we know it opens down. The y-intercept is always c. The axis of symmetry is always x equals negative b, so the opposite of negative 8, over 2a, so 2 times negative 2. Well, I got 2 negatives. The opposite of a negative is a positive, so that's 8 over negative 4, so x equals negative 2. So that's my axis of symmetry. It is also the x-coordinate of my vertex. But to find the y-coordinate, I have to find f of negative 2. So I write my equation. So negative 2 times x squared minus 8 times x minus 9. And instead of x, I'm finding f of negative 2, I put negative 2 in there. Negative 2 squared is positive 4. Positive 4 times 2 is negative 8. Negative 8 times negative 2 is positive 16 minus 9. Negative 8 plus 16 is 8, and 8 minus 9 is negative 1. So I know that my vertex is negative 1. And that y value helps me find my range. Since it's opening down, I know my vertex is going to be a maximum, and I know my range is going to be going down. And what number is this? It's the y-coordinate, or the k, of my vertex. But domain, remember, is always, 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 always all real numbers. Okay, 2 more. What about if there's a fraction? What do we do then? Well, a is 1/3, b is 2, c is negative 1. That means my y-intercept is negative 1. Since a is positive, it opens up. My axis of symmetry is x equals negative b over 2 times a. Hopefully you remember how to divide by a fraction and multiply fractions. So 2 times 1/3 is 2/3. So I have negative 2 divided by 2/3, and negative 2 divided by 2/3 is the same as negative 2 times the reciprocal, which means times 3/2. The 2's cancel, and I get negative 3. The axis of symmetry is x equals negative 3. And then I take and put the x coordinate, I make that the same as my axis of symmetry because it goes through the axis of symmetry goes through the vertex. And now I find f of negative 3. So I'm going to plug negative 3 in. So I do 1/3 x squared plus 2 times x minus 1, but instead of x, I put in negative 3. Negative 3 squared is 9, divided by 3 is 3, minus 6 minus 1. So that's a negative 3 minus 1. We're getting a negative 4 for our vertex y-coordinate. Our domain is always all real numbers, and sometimes I abbreviate it like that. And our range is going to be y is greater than or equal to, y because range means y values, greater than or equal to because it opens up, and whatever the y-coordinate is. That's where it starts. It starts at negative 3, negative 4, and goes up. And since it opens up, that's a minimum value. Right, last one. A is negative 1. Remember, if there's no number in front of it, it's just a 1. B is negative 4. C is negative 3. It opens down because A is negative. The y-intercept is C, so the y-intercept is negative 3. Our x-axis of symmetry is negative B over 2A. So that's a 4 over negative 2, or x equals negative 2. So that's my axis of symmetry. I'm going to find my vertex y-coordinate by finding f of negative 2. So I write down the expression without the x, and then I put negative 2 in for x. So negative 2, negative 2. Negative 2 squared is 4. That'd be a negative 4 because there's a negative outside. These two multiply together to be positive 8 minus 3. Negative 4 plus 8 is 4, minus 3 is 1. So my y-coordinate is 1. And then my domain is always going to be all real numbers. My range is going to be y is less than or equal to, less than because A is negative, so it opens down, and then the y-coordinate, 1. And since it opens down, that's the highest point, so that would be my maximum. So that's what you're going to get to do for homework. You're going to find A, B, and C, and find your vertex and your axis of symmetry. And that will help us graph later in the week. So good luck with that. M squared, signing out.